Hey everyone, Brian Beeler here with the Storage Review podcast, and today we've got a great conversation about all things AWS Cloud, and I'd like to welcome in Mai-Lan Tomsen Bukovec to join us today. Welcome. Thank you for joining.
Hi, Brian. Thanks for having me.
Well, you guys just had your annual event, virtual, as all things have been this year, seemingly. But you didn't let the virtual nature slow you guys down at all. You had a insane number of announcements across the whole cloud portfolio, and then specifically the storage components that you're interested in. Man, that was amazing. You did an hour session on the new stuff. What's your feeling after that? How'd you take that experience?
Well, it was a lot of fun to get up there and talk about the many different ways that we're expanding the storage portfolio. I think I could have frankly talked for an hour more and just gone into a little bit more detail on all the super interesting ways that people are using the different services. So, you look back across, frankly, almost 15 years of innovation of storage. And we just really feel like we're getting started, Brian. I mean, S3 was the first service to launch, first storage service to launch in 2006. And we pretty much opened up this new definition of cloud-based object storage. And we haven't quit adding and changing that definition since then. And EBS, we launched in 2008 for this pay-as-you-go durable attached storage for EC2. And, as you probably saw from the announcements this reInvent in the last few weeks, we continue to expand that surface area of all the different things you can do with block storage. So just a really exciting time. And we really think that, while we do have this really broad portfolio with a lot of depth, we are just getting started. Well,
I have to note that your session was a intermediate 200 level, and I was happy to have survived it. Now I feel smarter than I probably am by qualifying at a 200 level. I'm a little scared though of what 300 and beyond looks like.
Well, I think the fun thing about AWS storage is that we design and plan for simplicity in our storage. And our goal is to be able to run that gamut of 100 to 500 plus. And
oh my gosh, it goes all the way to 500.
Yeah. Well, I don't know if technically they have that level in the reInvent conversations, but certainly in the conversations that we have one-on-one with our customers in our meetings, we have plenty of customers that are doing absolutely amazing things with storage and really, coming back to us and asking for more capabilities and more features that, as I mentioned, don't traditionally fit in the definition of storage. And what that ends up doing is expanding, what storage means in the cloud. And it's all for this next generation of applications that customers are building. And it demands a modern data architecture, a modern data platform underneath it. And that's what we have with AWS.
So take just a minute, because you did start to highlight some of the offerings that back when you started, the Object S3 and then EBS. Will you just take a minute or two and kind of level set how you think about the storage offerings at AWS from the highest level? So sort of how do you segment the offerings, and then we can maybe get into some of the targeting via the types of volumes and things that you have within each one of those.
Yeah, absolutely. Well, I think, as I mentioned, the AWS storage started with S3 in 2006. And when we first built S3, we built S3 so that it could provide unstructured storage, which at the time meant a lot of JPEGs and backups for archive and video storage, basically those data sets that grow very fast. And what we've seen over time, and S3 is almost 15 years old now, is that the type of data being stored in S3 has changed quite a lot. And we still have a lot of traditionally unstructured storage, but the fastest growing data sets in S3 are semi-structured and some forms of structured data. And so structured data, for example, like Parquet files, are driving a lot of the analytics that applications are building on top of S3, and semi-structured data like CSV files drive a lot of the, transaction analysis and targeted advertising for a lot of online and traditional businesses these days. And so, if you take a step back and you look at object storage with S3, it's evolved over time in a way that has helped provide the foundation for what's a rapidly growing application set of machine learning, analytics, real-time advertising, and many different applications that you just wouldn't have thought of 15 years ago as being object storage driven. And so in 2008, we launched EBS, and EBS provides durable attached storage to an EC2 instance. So when you're using an EC2 instance, you can either choose to use local storage, which will go away when you close down or stop using the instance. Whereas if you wanted to have more durable storage, you would use an EBS volume that you attach to your instance. And you could choose to unattach the volume from that instance and change your instance type and then attach that storage to that instance and then that new instance. And we also provide snapshotting on top of EBS volumes, which make it really easy to create a backup and be able to, frankly, start from a backup as well. And so, those two storage services were, the foundation of AWS storage, but we've added a lot more since then. And, if you think about, for example, let's just take the file space. We have a number of different options for folks in the file space these days. We started off with EFS, Elastic File, and EFS has evolved really interestingly as a type of storage that a lot of people are using with containers. And so, think of EFS as simple set and forget, serverless shared file storage. And the goal there is to be able to have a easily understood or familiar protocol for EFS that integrates with all of our AWS compute models like ECS or Fargate or Lambda or EKS. And the ease of that integration has really driven a lot of usage of EFS with our serverless world and our serverless applications. We also have two separate managed file services that a lot of customers are using. And, the first one, the problem might sound familiar to you, Brian. We hear a lot from customers that they have crazy NAS sprawl in their data center. As you know, NAS-based storage, it's expensive, it's super hard to maintain, and, customers have a lot of it. And so a lot of customers start with their migration to the cloud by just moving, workloads like home directories or content management. And, if you can do that, you get the benefits of having that storage in the cloud. And the service that we've built for that is something called Amazon FSX for Windows File Server. And it's really designed to, make it easy to do your NAS migrations, but it's also the lowest cost for Windows file per unit in the cloud than any other provider. And so, when we're thinking about storage, we're not just thinking about these core building blocks like S3 and EBS, but we're also thinking about how can we take something that's as essential as file and be able to integrate that with our serverless world like our containers. And then how can we take something as fundamental as NAS storage and make that super cheap and easy to move to the cloud. And the other type of file service that we offer is something called Amazon FSX for Lustre. And we have a lot of customers who come to us and say, I want to do machine learning, I want to do HPC and really high performance processing. And they like Lustre, but they don't like managing the Lustre clusters, and they don't like having to deal with all the overhead of providing that type of processing. And so we built and shipped a very popular file service called FSX for Lustre, where you get that same sub-millisecond latency that you want from Lustre and tens of millions of IOPS, but you get it managed, right? And the service itself manages Lustre. So all you're dealing with is the performance of Lustre without any of the overhead. And so, if you think about that sort of step forward into the managed space, it really opens up the world for a lot of, smaller or medium-sized businesses who don't want to have the overhead of managing, a building block in the cloud, but they want the benefits of it. We have plenty of enterprises and other customers that are doing, these compute-intensive workloads too, but the managed nature of a lot of our storage services is extremely attractive for folks looking for that first step into the cloud. So that just sort of gives you an idea of file. But when we're thinking about, storage, we're not just thinking about those resources and those building blocks, Brian. We're thinking about the whole ecosystem of how do you get the data in to the cloud, and then how do you move data around while you're in the cloud as well. And so for that, we have this whole set of file transfer services. And, if you think about it, it's this whole category of data movement and migration, okay? And that can range from, our AWS transfer for SFTP, right, which we launched a couple years ago. A lot of customers still have SFTP out there. It's kind of a backbone of a lot of file transfer for a lot of B2B type of environments. And so we built this service, and it's basically SFTP without having to manage the servers. And customers really like that. So this year we launched AWS Transfer for FTPS and for FTP. And so that's like an example of where a customer comes to us and says, okay, file transfers in and out of S3 as an example. How do you make that easier? And the way we do it is we build a service. We also have this whole category of Snow devices,
right?
Which are,
cone, the ball, all that stuff.
What's that?
The cone, the ball, the truck, all of those guys, huh?
Yeah, we call it the Snow family, Brian, because we have a lot of these different devices, and some of them were originally designed for just data transfer, right? Where you're taking data from your data center and you're shipping it into an AWS region or out of an AWS region. Okay, so earlier this year, actually, we launched something called a Snow Cone, the latest of the Snow family. We launched it in June, and it's our smallest device. It comes actually pre-installed with something that we call Data Sync. We have a service called AWS Data Sync that makes it really easy to move data back and forth. But the way to think about Snow Cone, and if we were there in person, I would be handing you, Brian, a Snow Cone, because it's as small as a tissue box. It has, it weighs about 4.5 pounds. It's got 8 terabytes of usable storage, and we built it because we had a whole bunch of customers who said they needed very portable storage that you could throw into a backpack, for first responders, or you could even put on a drone if you wanted to. And so that's kind of where I was describing. It's not just these core building blocks that we've done for storage. It's the managed services that make it super easy to either migrate or just do high performance computing, for example, with high performance storage. And then this whole ecosystem of devices as well as services for data transfer.
But you just at the highest level unpacked like several cases of like legal documents. It seems like you dropped them on my virtual desk and said, here's all the stuff we can do. And that's sort of not quite, but getting closer to infinite flexibility within AWS is a big part of your success for sure. But also, ranging from petabytes of object storage down to an 8 terabyte portable thing for the edge or remote edge is such a wide swath of problem solving. When you guys are sitting around thinking about, okay, what do we need to do next year? What does 2021 or even 2, 3, 4, or 5 hold for AWS and our customers? How do you even start to segment what you want to go do when you're talking about like a Snow Cone versus some of the stuff that you've got that you launched recently in EBS, which is, SAN in type solutions. I mean, there's just such a wide variety there. I'm wondering how you guys think about that, or if you spend a lot of time on that in segmentation internally.
For us, Brian, it ends up being actually pretty straightforward. Over 90% of our roadmap comes from what customers ask for, and just about every single thing that we just talked about was a request, a very specific request from one or more customers. And just take that Snow Cone example. We had plenty of customers who are using the larger devices and wanted to take it on the road, if you will, and asked us to build something smaller for smaller data sets, and we did it. If you think about some of the launches that we did in this reInvent of this year, I think the thing that I always look to is how we don't let the notion of the traditional definition of what we do define what we do next. And I think the SAN in the cloud announcements that you heard were really a great representation of that. So EBS, as I mentioned, we launched it in 2008 to provide durable attached storage for EC2. And over time, what happened is that we heard that customers wanted to use these EBS volumes for both boot volumes for EC2, but they also wanted to use it for data volumes. They wanted to run databases on it. They wanted to run, Kafka installations. They wanted to do a whole bunch of things that really had to do with making an EBS volume a data volume. And, this year in particular, we got a lot of feedback from customers that said, just help us get away from SANs. Right? Storage hardware is so much sunk cost up front, and you have to predict what capacity you need. And customers get in a bind if they underestimate that. So they often overestimate how much capacity they need. And that's just like the very definition of inflexible and, not elastic. Another SAN to go and scale that out. And so with EBS, we already had that pay-as-you-go model where customers could scale up and down their data volumes. And what we did is we basically, we started actually, over a year ago, where we built a lot of our technology on something called SRD. Did you catch the SRD announcement last year, Brian?
Oh gosh, you're putting me on the hot seat, and probably, but at the pace that you guys are going, sometimes it's hard to keep up with all of them. So hit it again for me.
Okay, so it's super interesting, Brian, because the reason why we're able to innovate at the speed that we do is that we go all the way down into the guts of our systems to optimize for things like performance, or to change the consistency model that we recently did for S3 and move from eventually consistent to strong consistent for all requests. But just going back to EBS, we talked last year at reInvent, and again, it was one of many topics. So if you missed it, it's totally okay, because this one was an important one for EBS. We basically announced the scalable, reliable datagram. It's an SRD. We call it SRD protocol. And it's basically a new network transport protocol that we built custom for our Nitro platform. Okay, so it's designed to take advantage of commodity multi-tenant data center networks and basically send the packets for networking across as many network paths as possible and intelligently avoid the overloaded paths. Okay, so this was think of it as a very foundational networking protocol that we have built on top of with EBS, because what SRD lets us do is it lets us offload block storage operations into this AWS customized Nitro networking card. Okay, so think of it as offloading your storage operations onto hardware, our Nitro networking card, that was developed by Annapurna over a number of years. And what it did is it gave us this, foundation that we then built software on top of to really optimize. And then we have custom hardware as well to really optimize the performance of our Block Express, our IO2 Block Express, which has up to 256K IOPS, 4,000 megabytes of throughput, and sub-second low variance IO latency. And so once you get a profile like that, Brian, in the cloud, it starts to open up being able to stop ordering all those SANs and move them to our provisioned IOPS volume type, EBS's IO2. We did this preview just a couple weeks ago of Block Express, and we'll launch it sometime next year. And that is the first cloud SAN that is available from any provider. And it's uniquely built by us because we are able to go all the way down to that custom network protocol and the custom hardware in our data centers, and then build up from there.
Yeah, so wow, there's a lot there. And I guess this is just a logical extension, though, if as you started back in '08 with the EBS durable volumes for compute, where you had snapshots, you've essentially taken that start of the progression and added more performance and more enterprise SAN capabilities, which is the driving notion to be able to call this a SAN in the first place, I suppose, in the cloud. The performance profile is interesting. I mean, for a lot of mainstream applications and workloads, that should be plenty. Will customers be able to aggregate these express volumes if they need more performance?
Yeah, they will. Over time in our preview, we don't have the multi-attached capability for Block Express. It's just because we wanted customers to be able to trial the performance first as part of the preview. But certainly on release, we will, on general availability, we will offer things like multi-attached, so you can stripe together different IO2 Block Express volumes and have that capability as well. So, I think the way I would think about IO2 is that we launched IO2 as a volume type just this year in August, actually. And it was our first 5 nines durable volume type for EBS. And then we're layering on top of it with multi-attached support. So you can stripe, you can attach it to up to 16 different Nitro-based instances. And then we do this preview of the SAN performance with Block Express that will launch sometime in the upcoming year. And all of that basically sets up IO2 as the high performance volume type with all the elasticity that you just can't get in a data center. And Brian, one example of where this is unique as well is around our pricing. And so when people are using IO2, they're going to scale by the dimension of IOPS. It's just the nature of the workloads. And with IO2, we introduced volume-based discounts on IOPS. And so up to 32,000 IOPS, you pay the standard price, but 32,000 to 64,000, you get an additional almost 30% discount. And then any IOPS usage above 64,000, you get another discount on top of that. And that is just so counter to how people think about the provisioning process of a SAN and a data center. This idea of, pay less as you use more, as you scale up and down elastically for your block storage. That is the nature of EBS and the layers of innovation we're adding, which is in turn giving back that flexibility to customers.
Yeah, well, it's really interesting because, as you said before, most array purchases are done on a capacity basis and a performance basis. So what sort of performance needs do I have, and how much stuff do I need to store? And you're absolutely right about not having a great handle on data growth, and do I really want to have to go buy, especially now with all flash systems, do I really want to have to go buy another shelf of flash in a year because I misjudged our growth and have to go explain that we've got another CapEx hit to our financial guys? They don't tend to take that that news real well. but some of the array guys, and I'm wondering how you take this, because some of the array guys, what they're doing is say, okay, well, get something that that you think is going to be great, but now we've got cloud connectivity, so we can use Amazon services and maybe even S3, so it's a little bit more cost effective, and tier your cold data out to the cloud. So now you've got your primary, your active hot data on your new flash system. And as you grow, we can tier out the cold stuff. So that's still a win for you, but in the AWS perspective, but is a little bit different than just going all in on cloud. And I guess it depends too, and what your vision is of a data center, on-prem versus all in the cloud. But that flexibility that the array vendors are starting to get to, they're not all doing it. NetApp's done a really nice job of it. Starts to give a little more flexibility to organizations looking at storage arrays. Have you considered, or what's your take on that?
Well, Brian, we have a ton of storage partners, and we like and work very closely with our storage partners, because for us, it's all about optionality for customers. If a customer wants to work with a storage partner because it just meets them where they are, we want to support that in any way that we can, because it's all part of a customer's journey to the cloud, and everyone's going to take a different path. That said, what you're talking about there around tiering and being able to optimize for things like cost and performance, but in a more managed way, that actually can be done directly within the services as well. And so, as an example, in November, we dropped the cost of SC1, which is an HDD EBS volume type for colder storage. We dropped it by 40%. And we lowered the minimum size of it from 500 gigabytes to 125 gigabytes. And so if a customer has colder storage, it's really easy for them to use our elastic volume feature in EBS and just convert their volume from, say, one of the SSD volume types to this SC1 volume type, where you get this much lower cost of storage, but you also, you also get the same characteristics of EBS block storage. And so, all of those tiering capabilities are in the storage services as well, but you're also going to, when you're using the storage services directly, you're also going to be able to benefit from, the innovation of the building blocks. And, one of the things that we announced at reInvent is a new EC2 instance called R5B. And R5B is the largest EBS optimized EC2 instance, and it gives you up to 60 gigabits per second bandwidth with 260K IOPS of EBS performance. It's the fastest block storage performance on EC2. And so customers who use R5B as an EC2 building block with Amazon EBS IO2 Block Express as a storage building block can get the benefits of the IO2 Block Express performance that I talked about on an EC2 optimized instance. So you have that sort of customization of, just kind of raw performance you can do at the building blocks when you're going directly to the resources. I think I would also add there, Brian, that if I think about new services that we launched a couple years ago, it's actually a storage class called Intelligent Tiering for S3. We've built a lot of that into the storage class. Brian, have you played around with intelligent tiering? Are you familiar with it?
We've done a lot of work around S3, but not the intelligent tiering specifically, no.
Yeah. So this is, what I love about intelligent tiering is that it is another way that when we think about how we build and take forward our storage services, we're not thinking about traditional concepts of how storage works. That's not how we roll. And the thing that we focus on is what customers are doing today with storage, with these modern applications, as well as migration of existing applications. And how can we build this next generation modern data storage for those type of applications? And so when we built intelligent tiering, we did it because we heard from customers that they didn't want to analyze access patterns in their data lakes. And I talked about how S3 now, kind of started off with unstructured data and now has just about every type of data you can think of. It's also grown the concept of a data lake to include many different types of data sets. And whether it's customer care recordings, or it's our Parquet files for analytics, or it's the data, the source data that feeds into machine learning models, it's all in S3. And it's used as a shared storage layer for dozens, sometimes hundreds of applications that use either some of the data sets or all of the data sets together. And so the storage class intelligent tiering has built-in object monitoring, where it keeps an eye on the access patterns of your storage. And if an object is not accessed in a month, you get the same price that we charge for storage for our infrequent access storage class, which is built for data that's accessed maybe once a month. And if it's accessed frequently, you pay the same price as standard. These are not sort of custom prices. It's just the same as standard or infrequent access, the other storage classes. But most importantly, we don't charge retrieval fees. And so for the infrequent access storage class, if you use that class directly, it's cheaper than intelligent tiering. It's roughly 40% cheaper than standard, but you have to pay a data retrieval when you retrieve data. And for the intelligent tiering storage class, not only do you have the built-in monitoring, but you get dynamic pricing on your storage depending on if it happens to be accessed a lot or not in a given month. And in November, actually right before reInvent, we launched 2 new archive tiers into intelligent tiering, where again, just if you use a storage class, you can now configure your storage to say, after 90 days, if nobody touches my storage, put it into an archive tier, which is, again, Glacier. It's just another storage class. And after 180 days or more, put it in Deep Archive, which is $1 a terabyte per month, cheaper than tape and better, and do it automatically for me. And so that is why that kind of automatic monitoring and smart placement without the retrieval fees or lifecycle tiering fees, it's all covered by the storage class, is why it is turning into the default storage class for customers who have data lakes. And because you don't have to pay any attention to it, you just get the discounts based on what the storage is doing. And again, Brian, there's nothing like that in on-premises storage today, but it's how we think about the evolution of storage, because that's what customers want for the applications that they're building on those data lakes.
Well, certainly the policy-driven approach to move things all the way out to Glacier, as you say, is really interesting and helps from a cost management standpoint. No doubt about that, and providing some intelligence too to help customers manage that is pretty cool. Is there a path to go from EBS IO2 instances to S3 in a tiering methodology, where if I'm going to use this Amazon SAN, could I backfill with S3 sort of or auto tier with S3 as some of the on-prem storage guys are doing?
You're not able to do that today, but we're constantly listening to what customers are asking for, and if we collect requests like that, we'll certainly look into it.
Okay, it's an interesting growth area. I think because customers just struggle, I think, sometimes with understanding their workloads and their performance needs, and data just ages out, and no one wants to delete anything. Have you ever coached your customers on deleting old data or inactive data?
Yeah, it's interesting. We make it. We introduce, as you say, the policy-driven lifecycle policies. Those basically let it give customers a policy-driven way to delete data very easily. What we actually find, though, is that particularly, customers know that every business these days is a data business, and that data drives a lot of decisions that a business needs to make, particularly in a year like this one where, it's very hard to predict what will happen. And so customers want to grow their data without necessarily deleting it because they don't know if they're going to build an application 2 years down the road where they kind of needed that historical data. And so for those customers, they tend to just put their storage in the most cost-effective place, which is Glacier Deep Archive. It's $1 a terabyte per month. And you can, people either use it for long-term archive. Sometimes they actually use it as a recycling bin, Brian, where they think they can delete it, but they're not quite sure if they want to delete it.
Not ready to pull the trigger yet.
Right? They're not quite ready to pull the trigger, but they're like, okay, I'm going to go put it in Deep Archive. And if nobody asks me for the data in 6 months to a year, then I will be comfortable deleting it. And then other customers just, they put it in sort of a long-term hold, if you will, in Deep Archive because they're not quite sure if it's going to come in handy because so much of machine learning these days are driven off of diverse data types. And, I'll tell you, Brian, I was talking to a customer in the financial sector. And, this super interesting pattern with S3 where you have all these different data sets that people put into S3. And it's very different from a data center where the data set is tied to the application, right? And it sort of, by definition, ends up being a data silo because that storage is used by that one application and it's kind of hard to have it be used by other applications in an on-premises world. And what we see in S3 is that it ends up being this very large, data set of different types of data in S3. And what this one customer in the financial sector found is that their fraud detection department started to look around in their data lake to see if there was other data sets that they wanted to feed into their machine learning model to look for fraudsters. And they saw there was a ton of data for customer care recordings that were stored in S3. And they were stored in S3 because it was cheap, right? Those are big files. There's a lot of them. And but the fraud department got the idea of starting to incorporate and look for sort of patterns in customer care recordings to see if it could inform their verification models. And they found some stuff. They found some tells on what fraudsters will do when they call in. And I can't share any of the details there because it did go back into a lot of their thinking. But it improved the validation of finding the fraudsters and validating that that and correlating patterns by a number of percent in their model, and that's actually quite a lot when you're looking at fraud detection. And so but that sort of thing, Brian, that would never happen in a traditional data center where the data is specific to the storage. And there's not this idea of saying, hey, I see you have 10 petabytes of customer care recordings. I'm going to use it for my machine learning model. And then just trying it just like that because, it's an experiment and then finding value and then taking it forward. That's what you can do in the cloud, though.
Well, I mean, that's a sort of a native cloud win, though, right? Because you can scale up your compute, too. And I know you've talked about it a little bit on the edges, but if you're in AWS and you've got this massive data set and all of a sudden you've got a data scientist that says, hey, I think we might be able to do something with this old data, but we also need to spin up a number of machines with GPUs or whatever it is, right? They can do that, connect to the storage and be off and running in quickly rather than the comparable of building that infrastructure on-prem could take weeks at least, right?
Not just weeks, but also with a significant amount of cost. And I mean, this year was a great example of where a lot of customers found that to be true. There's this company up in Ontario called OTN. It's Ontario Telehealth Network. And it's a not-for-profit. It's an independent not-for-profit, and it's funded by the government of Ontario. And the idea for OTN was to deliver, telehealth services, the largest virtual care network of telehealth services, and give 24/7 access to users. And as you might imagine, this year, OTN got a significant increase in users. And in fact, they went from 8,000 to over 30,000 very quickly. And as you said, Brian, that was because they were able to scale up EC2, Lambda, S3, just a list of AWS services that OTN builds their telehealth services on. And to go from 8,000 users to over 30,000 very quickly is something that would be unheard of when you're thinking about traditional kind of enterprises. There's another example that makes me think of, that auto scaling, if you will, which is Experian, which is, a credit bureau and a well-known player for credit monitoring. And they have this app they called Ascend that they built on the AWS cloud. And it was an app that, grew basically from 50 million in revenue in 2018 to 207 million in the first quarter of 2020. So they were able to scale it significantly based on steady state growth. But then when this whole thing hit this year with the COVID situation, they wanted to pivot as quickly as they could to help their customers. And so because they were built on AWS, this Ascend application was able to create a special product, in our analytics tools.
The puppy loves snow cones and analytics tools, apparently.
Yeah, it's. I think our mail is being delivered or something.
It's quite all right.
Okay, but so what Experian did is that when the COVID situation hit, they wanted to create a new product very quickly. And the new product basically was a new analytic tool that would help the customers that they have understand how the pandemic was affecting markets worldwide. And the key thing for them was being able to create and launch this product within 30 days, okay? And you're not going to get that type of agility and the ability to kind of pivot on the current situation and give the products to your customers that they need to manage the situation without having that type of, as you say, the promise of the cloud, the ability to not just spin up your resources up and down, depending on what you want to do, but also use it to create new products in almost real time.
Yeah, I mean, it's that highlights all of the benefits of the cloud, in a couple pretty succinct use cases. So as I'm thinking through what you guys are doing with the Express volumes, and I know you've got some new Flash volumes as well. Can you talk at all about the impact of hardware and how much, I mean, obviously your teams are always thinking about that. You talked about Nitro a little bit already, but with the advent of new technology, whether it's new flash drives or networking or server CPUs from AMD, clearly the compute side of the house is offering a number of types of instances based on those technologies. How much of new storage stuff do you guys get excited about, and then how does that eventually translate into the products that you offer?
Yeah, absolutely. I talked. I have two examples I want to share with you that kind of illustrate it. Let's talk first about EBS, because as I mentioned with Block Express, IO2's Block Express preview, that is all the way down to custom hardware, custom network protocol, custom software to give you that type of SAD performance. You mentioned the other SSD product that we launched, GP3. GP3 is a general purpose SSD-based volume. We launched GP2 back in 2014, and it was the first time anyone had offered that type of price for performance with the simplicity of being able to buy capacity and get IOPS and throughput to go with it. And then, and people just started using it like crazy, either for boot volumes or frankly data volumes as well. And so this launch that we did for GP3 actually extends the capabilities of throughput by 4 times with a 20% less storage cost. And so that type of innovation, not just on cost, but also on performance, and then also adding the flexibility to be able to, for example, buy some capacity and then provision throughput and IOPS on top of that as separate entities or separate dimensions, is part of the engineering that we do at the software layer, but a lot of the capabilities go all the way down to custom hardware that we built. And so, if you think about what you're getting for any storage service, you're actually getting that. You're getting, the benefits of the AZ-based architecture for our regionalized services. You're getting the benefits, for example, for EBS Block Express of offloading storage operations on the Nitro card, right? So hardware offloading of storage operations. And in S3, when we're making changes to S3, we're also doing the same deep dive into all aspects of storage. And so, if I think about the change that we introduced for strong consistency, Brian, are you familiar with eventual consistency that S3 launched with and strong consistency that we just launched?
I did see the strong consistency announcement, yes.
Yeah. So, when S3 was first launched in 2006, Brian, a very common use case was where customers would use it for e-commerce sites. It would be static images used for e-commerce sites. And so the idea with eventual consistency is that when you put your storage into S3, the storage is there, but the metadata is eventually consistent. The vast amount of time, the metadata is consistent, which means that when you try to list to find your object, you see it. But sometimes it was eventually consistent because the design of the system optimized cost, performance, and availability, right? But as I said, the nature of the applications using S3 has really fundamentally changed to expand to real-time processing, analytics workloads, machine learning, the whole 9 yards. And so applications, or frankly code, has a harder time with eventual consistency, right? Like, applications have to extend S3 to have a metadata system to manage consistency, to make sure that when they're interacting with the storage, they're treating it as a strongly consistent storage layer, which is what a lot of analytics applications expect. And so we went back into S3, and we have over 200 microservices in S3, and we had to go back and build strong consistency all the way down into the guts of S3. Make changes, hundreds of lines of code in order to add strong consistency without adding cost, without changing performance, and without changing any of our regional isolation for S3 within a region. And, when you're making a change like that, this is the other part where technology factors in. For something like strong consistency, it's very hard to validate, because you can have these race conditions, you can have, a lot of different edge conditions where you can say that you have strong consistency, but in fact, in certain race conditions, you don't. And so we used something called automated reasoning, or formal verification or validation, which is basically mathematical proofs for correctness. And we actually do this in a bunch of different places in S3, where we actually have mathematicians who sit with our software engineering teams, and they are building mathematical proofs to demonstrate and proof, essentially, the correctness of a protocol, as an example, or in this case, the correctness of consistency, strong consistency in every request. And that mathematical proofing lets us validate millions of different state combinations in a mathematical proof to make sure that when we say we're going to be strongly consistent, we are. And in fact, it found some super subtle bugs, Brian, that in no way would we have been able to find, even by writing many, 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 many more test cases than we already have. And we were able to find it because we came at the problem in a different way. We came at it from a math angle, and we proofed it. So that's another example of where it's not just customization at the hardware layer, and it's not just a lot of deep engineering at the software layer. It's also taking these different, modern practices, like applying automated reasoning in your software engineering process to help us achieve these really big changes for our customers.
Actually, you guys are hoarding up the math nerds now too to solve storage problems. That's
well, I got to tell you, Brian, if you work on storage in any capacity, you got to be a math nerd. We just are now attracting many more of them.
I suppose so. So you talked about GP3, which is interesting in a progression in your SSD offering. From a high performance storage standpoint, something that the on-prem equivalent might be an end-to-end NVMe array for that tier 0 kind of that need. Do you see that as something more from an AWS storage perspective, or do you see EC2 high performance storage instances as the answer there? How do you think about that particular need?
Well, I think, it kind of goes back to that optionality, right? That we talked about. I think you're always going to be able to, okay, so if I take a step back, EBS volumes are already exposed as NVMe block devices, but they're 4 instances built on the Nitro system, okay? And so I think, if I were to think about, it kind of goes back to how the different building blocks work together, Brian. I think you already have that being exposed in that way. I think there's a lot of future investment that we're going to continue to do in that space as well. But, you already have that kind of fundamental concept built in.
Yeah, I just wonder, how much, you talk about what customers want and, letting that drive your vision. I'm just sort of curious about what the demand looks like for, I don't even know what qualifier to put on it, ultra high performance storage or, something like that in the cloud, which is often in the clouds done via bare metal on the server side, but, just wasn't sure what sort of direction you guys were looking at for flash performance from a storage perspective.
Yeah, I think we do get interest in those super high performance workloads. It's actually where we're targeting IO2 to go. That's all going to be built into that platform of the first cloud SAN. If you think about GP3 is optimized for the best price for performance, but it's really used for general purpose type of workloads. We have a fair number of customers who run Cassandra and other applications on top of GP3. But that high-end type of workloads, those will go to IO2 over time. And so I think the place that a lot of customers are starting is, it's benchmarking and trying to figure out how to take advantage of the IO2 platform and to think about getting away from those SANs and into a different model, which, as you know, Brian, sometimes will take some time from companies to think about. I mean, we say, if I think about it, sometimes like what we found with customers is that the biggest blocker to migration to the cloud is really not technology, right? Like the biggest blocker, like if you look at technology, AWS has more services and more features within those services, and just a proven track record that if you want something, our roadmap is 90% driven by what customers want. And so, the challenge there isn't really technical. The biggest challenge for cloud computing is really people and culture. It's resistance to change or fear of the unknown. And organizations basically have to lead through that. And so when customers are thinking about, is this the year, is now the time to change? How do I think about SAN purchases, which for many customers have been the way it's done for decades, right? Or years at least. That's a change. And that's a change in that an organization has to drive through. And, often it's a change of culture, of mindset, of thinking about storage in a different way. And that's what we see as being often the biggest blocker to moving to the cloud, because it's really not the technology. The technology is rapidly evolving, and customers know that if they're going to need something and they ask AWS for it, we will listen.
Well, it doesn't help that their traditional infrastructure partners are somewhat vested in certainly the successful outcomes, but moving more hardware is also kind of fundamental to their businesses for now anyway. So it'll be interesting to see how that changes. So I want to ask you one last thing before we conclude here. You talked about customers driving your roadmap. 90% of the new launches come from bulk of customers asking you for something. But if I know anything about customers, sometimes they're not all that organized in actually what they want. Have you had, or I'm sure you have, but what can you tell us about a little bit of pain, or maybe something that you did that customers asked for, and once you gave it to them, they're like, sorry, my bad, dog. We didn't really want that. Do you have a successful failure story?
Well, let me take that from a slightly different perspective, because I think you're correct that a lot of customers who are moving fast and trying to do this shift to the cloud, sometimes what they're asking for is a solution, right, to a problem. And so, I'll give you an example. I talked about the evolution of these diverse data sets coming into a data lake. And what that ends up being is basically a very diverse data estate, where you have lots of different data sets and they're all growing at different speeds. And the person who's trying to manage the growth of storage has to wrangle all of that, right? It has to wrangle, what teams and what applications are using what data and how is that growing and is it runaway growth? And so that was something that we heard from customers, frankly, large and small, which is, I have hundreds of accounts or just even dozens of accounts, and each of those accounts have, lots of buckets. And how do I view even the usage of and the growth of my storage and the trending of it across all of those accounts and buckets? And so we built something called Storage Lens, which is something that lets you look across all your accounts and drill down into individual trends, like which prefix is growing the fastest, or which bucket is growing the fastest. And that is across all your accounts in your organization. And it's got a ton of analytics in it. It has recommendations for encryption if you have some of your data not encrypted. It looks at your access policies and it says, hey, did you know that you had public permission set on this data? But what's interesting about this too, and this goes back to your question, Brian, is that we came up with a bunch of reports that you can view in your console. Okay, like you just go to AWS Management Console, you go to S3, you turn on Storage Lens, and 2 weeks later, it has looked at your data and your trends, and it gives you these really nice bubble charts and line graphs, and it just shows you all your trends looked across all of your accounts. But to your point, Brian, sometimes what the customer actually wants is maybe not the reports that we give them. Maybe they already have reports, right? And their whole business is set up on a certain set of reports. And so we dump the raw data that we're using for all of our reporting into Parquet files in the S3 bucket that the customer owns. And then what the customer can then do is not just use our view, but they can use the raw data too. And they can use that to just simplify their governance and oversight of their larger data estate. And so that's how we kind of approach it, Brian, is like when we're talking to customers, we kind of look at the problem that we're trying to solve. In this case, we followed around a bunch of folks and we said, okay, tell us how you're reporting to your board of directors or your CEO about storage growth. We looked at those graphs, but we also know that customers want options. And so we built the feature such that they could take the raw data in those Parquet files and do anything they wanted with it.
Well, yeah, I think the visibility into data is huge, and that's a very worthwhile investment for you guys to be doing, not only to make administrators' jobs and lives easier, but like you said, to be able to justify the value ultimately that you're providing. So makes a ton of sense. And I mean, this has been a great conversation. We need to probably do this again before a year is out, because while you had a bunch of announcements, and we'll link to those in the show description from your annual event. I mean, you guys are on a pretty hefty rolling thunder, and you're not exactly saving these up. So one clue before you go, one clue as to what to look for into next year.
I think, Brian, if you look ahead to 2021, you're going to see a lot more movement for our EBS SEN in the cloud. It's a major initiative for us. We know a lot of customers love GP2, and they're going to love GP3. We announced GP3 a week ago, and honestly, the uptake on it has been absolutely nuts. Customers are adopting it at scale. And we'll always keep investing in things like our general purpose SSD volume types, but really look for, in 2021, where we're going in our first sound for the cloud. That's going to be really exciting to watch. And I think on the S3 side, I think it's going to be, we're thinking about a few other things that we are going to launch, which again, kind of fundamentally change the notion of object storage. And that's the direction of S3. S3 over time has changed very core attributes of storage, the definition of object storage to adjust to what customers are doing with their applications and their usage of the data. And we have a few things planned for next year, which will make it even easier for those applications to use the vast amount of storage, hundreds of petabytes, in some cases exabytes, in data lakes that customers have today.
Well, that's awesome. I appreciate that perspective. GP3, like you said, is available now. IO2 block express volumes preview now, available soon-ish, right? Okay.
Yeah, we're working on. It's in preview now, so we encourage people to try it and kick around the tires from a performance perspective, get a feel for it, and we're looking to launch it in 2021.
Awesome. Can't wait. And we will definitely be taking a look at that. And I will make sure to report back our findings once we've got some time to dig in there. Mai-Lan, this has been great. Really appreciate your time. And we'll have you back again soon. Thank you.
That'd be great. Thanks, Brian. Great talking to you.